Hi, everyone. This is Greg McPhee from Casten. Thank you for joining today's webinar on data protection made easy, specifically Kubernetes data protection. And so I am your host, and I'm going to take you through a couple slides and a demo, answer your questions, and just show you how easy it is to protect Kubernetes data. So I hope this will be meaningful for you, a good use of your time, and we might even finish up a few minutes early. So a little bit about me. I've been working for Casten for just over 3 years. Casten is a company that Veeam purchased about 3.5 years ago. Veeam is the #1 data protection software in the industry, has the most customers, has the largest revenue. It is a product that has been maturing for 20 years, really, with the evolution of vSphere. But when Kubernetes came out of the closet and began to become mainstream, and it started underpinning phone applications and AI, we quickly came into a situation where, okay, now we're creating data that we need to keep. We have data that is sellable, right? It's currency. And I'll give you an example. A couple years ago, if you got on your phone and you said, "Hey Siri, who won the football game last night?" a container would wake up, it would interpret your voice, figure out your question, and feed you back your answer and shut down. And that was it. And nobody really cared about that transaction because it was just checking the football scores. But what if I said, "Hey Siri, how much does a new Toyota Corolla cost?" Well, Siri would do the same thing, spin up a container, listen and figure out what my question was, go look up the prices of new Toyota Corollas and give me some options back. But that question is a question that maybe Toyota wants to pay for, or maybe car dealers want to pay for. And when you start piecing together other pieces of information about me, it's not too hard for a container to figure out, hey, if I keep track of every time somebody asks about the price of a new car, I can sell this database, and I can sell it to car dealers, I can sell it to car manufacturers, I can sell it based on where people are at. But that information has to be accumulated. And if that information was lost, then you would lose the ability to sell it. And so you need to protect it, because if you have an outage, either man-made disaster or just whatever reason, and you lose that data, you want to be able to recover it. So that's where we're at with what are called stateful applications. And these stateful applications just simply mean we went from containers that kind of spun up and spun down and didn't do much except answer your question to containers that are spinning up and now looking deeper into the questions and deciding, how can I sell this information? So you've got that component of Kubernetes. And then you've got a second sort of industry changing event, which is that people right now have been running VMs inside of vSphere for years. I mean, 2+ decades. And VMware is a very mature, stable product, and virtualization changed our industry. But with the acquisition of Broadcom and the price hikes that have come, people have decided, I don't like to get pushed around, and I want to know what my options are. And so we're kind of at this inflection point of, what do I do here with this upcoming price hike that I might be getting? And do I just pay it, or do I reduce my licenses to bring my costs down, or do I move to another platform? Well, one of those other platforms, being Kubernetes, has come along and said, you know what, maybe what we can do is bring those VMs into Kubernetes. And so the KubeVirt project was created, and there's a couple folks like Red Hat or Rancher that support VMs inside of Kubernetes. And so people are thinking, well, if I'm already building a Kubernetes infrastructure for my modern applications, can I go ahead and drop VMs in there as well and kind of have one platform? And the answer is yes, you can do that. I'm not saying it's done with the exact same tools that you are used to. It is a fairly new feature, and that feature needs a little time for companies to come along and add features to make that experience the same. But it is rapidly moving in that direction, and there's a lot of work being done to make your experience inside of Kubernetes work like your experience inside of vSphere. Not there yet, but coming along that way. So you've got this flexibility with your platforms. Am I using it for containers? Am I using it for VMs? Am I using it for both? And I've still got to keep data that I care about. I need to be able to back it up, and I need to know that I can restore it. How quickly can I restore it? And I need to know how long is it going to take me to come back up if I have an outage. So inside of this whole virtualization platform, you've got 20 years of doing it one way. Now you've got Kubernetes coming in, and Casten was built to address the backup and data resiliency inside of a Kubernetes cluster. And Veeam saw the growth of Kubernetes and saw that the right approach and the right architecture matters here. And the right approach was to use a product that is Kubernetes native, not a product that sits outside of Kubernetes and uses agent or something that's still Windows-based, because some of these customers, they want to get off of vSphere, and they want to even sometimes consider getting off of Windows. So they wanted to get a platform that would work natively inside Kubernetes. And so you've still got these VMs that need to be protected. They need to run. They need to have the uptime that they're used to. But you've got this Kubernetes platform adoption that is just accelerating. Almost all of your DevOps stuff, right? It's happening inside of containers, and those containers need an orchestration platform to keep them up and running, keep them functioning, keep them out in front of your customers. Because if you look at, almost all the apps on your phone, right, they're underpinned by containers, and containers are orchestrated by Kubernetes. And so anytime you've got that kind of, critical functionality, you're going to want to protect the data that is created and used for those systems. And so you also have deployment models that you want to keep in mind for, am I going to optimize for VM? Am I going to optimize for containers? Am I going to have kind of a hybrid of both? So containers, interesting enough, a lot of organizations are using them at different stages. Not necessarily they're using them like in full production, but they're planning for deployment very soon. They know that the skill sets that are out there and the talent base that's coming in prefers to use a pipeline type of model to build applications, and that's container based, and those containers need a platform like Kubernetes to run on. But only 25% of them are backing up their data. And give them a little slack, because when Kubernetes first came out, most everything was ephemeral, which meant it just appeared and then it vanished. It was spin up, spin down, spin up, don't care about the data. If something goes wrong, if something gets corrupted, we can just recreate it. We can use our CI/CD pipeline to roll out the application again, get us back to where we were. And that was kind of one of the nice things about Kubernetes. But that was all fine and great until you had data that you had to keep, data that you were accumulating, formulas and algorithms that you were running that said, hey, I've done some, chewing through this data, and I think I've got something that people would purchase. And so now you've got a gold mine, and you want to protect that data. And so Veeam Kasten is here to do that. And we do that with a unified data resilience platform, whether you're using KubeVirt for VMs or whether you're doing containers. Having the single platform to handle both can reduce complexity and cost. The other thing is, since Casten is Kubernetes native, it is fully aware of whatever authentication you prefer to use. So it's just going to kind of piggyback on that authentication scheme that you're using. That allows you to, use Kubernetes, people who log into it, what rights that they get, RBAC type of things, that compliancy isn't jeopardized or altered in any way with the presence of K10. And this is going to help accelerate your modernization, because Casten isn't going to come in and make you do things differently. It's going to work exactly within your GitLab or Git type of operations, your CI/CD pipeline operations. They understand cloud native applications, which is what K10 is. So we basically keep your business up and running if your business is running inside of a Kubernetes cluster. So what exactly does K10 do? What are the use cases? Well, you've got backup and restore. Backup is kind of, some ways it's boring. People, they understand, well, I back up my computer at home. I may back it up to OneDrive, or I back it up to a external drive that I attach to it. I back it up somewhere. You've been backing up your VMs for years, so it's no different that you should be backing up your data inside of Kubernetes. But really, the interesting part is on the restore part. How quickly can you restore? To what point can you restore? And can you do that efficiently? And so things like dedupe and compression and incremental backups can help reduce how long it takes to back up and how long it takes to restore. And then, of course, once we've backed up your data, now you've got new options available for you, like how can I use this product, this tool, to help me in the case of a disaster? I've lost my primary cluster. How do I get another one up and running and get it back to where my primary one was? Well, Casten can do that. Casten, with its backup capabilities, can be constantly exporting to a third-party endpoint, like an S3 bucket of your choice, an NFS location. And once data is there, that's kind of the linchpin that allows another cluster to come into that endpoint with the right credentials and pull that data out. And when it pulls it out, it can restore it. And now you're going to have a secondary cluster that's up and running in a matter of how long it takes you to roll out the new cluster and to import the bits, across the wire. But if that's all we did, that would be great. That would be good, but we can do better. We can also help you when you're transitioning. We've got a lot of customers who are constantly kind of looking at the cloud costs to run, AKS or EKS, or, to look at them and say, well, if we need to move from one cloud provider to another because we're getting a sweetheart deal over here, with, say, Amazon, and then Azure comes along and does better, and you want to moving between clouds, moving between on-prem solutions, that does involve different environments. So your OpenShift cluster on-prem is gonna feel and have differences than your, say, vanilla Kubernetes running in Azure. And so when you migrate the applications over, having the ability to recognize those differences and apply them helps with, okay, when I restore the application in a different environment, it doesn't restore broken. It doesn't restore with all these little details that you got to go in and fix. It restores in a healthy state and it's up and working. I'm actually going to walk you through in the demo a little bit of that. And then, of course, ransomware protection is very important these days with the rise of ransomware attacks. We support immutable locations, And so if you back up to these immutable locations, then you know your data hasn't been tampered with, and you can restore with confidence that that backup has not been affected. Okay, so some of this I've talked about, but we'll just run through a couple of these slides real quick. So multi-tenancy, whether you would like to present your Kubernetes cluster as a service, and you can have portals that allow your developers to provision what they want, whether you're trying to do things like you own the cluster and all the developers have to go through you. I mean, however you work that, however you manage that, Casten is not going to, take away your options. You're going to be able to have full multi-tenancy support so that people who log into Casten, they only see the namespaces they're allowed to see. They don't even know that the namespaces of Pepsi are sitting next to the namespaces of Coke. Like, they don't even see it. And as I mentioned, full RBAC control. And K10 also supports scalability and performance. What that means is you can turn the knob a little to the left if you need K10 to shrink down into, say, resource-constrained areas, edge type of deployments, or you can turn the knob to the right and fatten it up, which basically loads more containers, more threads, which allows us to do backups in parallel or more parallel, so that we can get backups done faster. And then as far as disaster recovery, whether you need support across multiple zones or regions, even between cloud providers, and that support is going to require application transformation. We support that. We have near zero RTO, and that near zero is basically how often do you want to do your backups. If you want to do them down to 5 minutes, that's fine. And then you want to do your imports every 5 minutes, then you'll be 5 minutes behind. But that's probably just a few applications that would need that type of small RTO, as to where most applications you're probably going to do once an hour. But again, that's fully up to you, your control. And then with the application mobility, the idea here is if you need things like replica counts to change, if you need annotations to be removed or added, these things can be done during the restore. And so that means that you get your application up sooner. You don't have to spend time touching the application after it's been restored. This has also been very helpful for when you've got, say, a Kubernetes distribution, like let's say you're running 1.3.0 and you've kind of been unable to do upgrades along the way, and now you're at 1.3.5 and you're like, I really like that new feature that's in 1.3.5. How do I get from 1.3.0 to 1.3.5? Well, you can step all the way through the 1.3.1, 2, 3, 4, 5 if you would like to. But the other thing you could do is just deploy a new cluster at 1.3.5 and use Casten to just move everything over. And so then it's kind of like you can just leave the 1.3.0 up for a while to make sure everything got over. And once you verified that, you can shut down the 1.3.0. That's a much quicker path to getting you upgrade than stepping through all those iterations. And then of course, ransomware protection is really about giving you the assurance that when you put stuff into a bucket, that it's going to be there untampered, watching that, monitoring that, and being able to go back to specific point in times. You may know that an application got corrupted at noon, so you want to go back to the 11:30 and do the restore versus going back to the 11:45 where you're not sure if it got corrupted or not. In other words, you're going to have full choices of all the backups that you've ever done, and we're also going to keep a retention schedule according to the policy you set that will keep the application backups around for a period of time, meaning that let's say we're backing up to an S3 bucket. Well, that S3 bucket on Amazon you're paying for. And so you want those backups to be, say, a month old. and you don't want anything more than that just simply because you're going to consume space that you have to pay for, we can keep those backups to a month. We can automatically do the cleanup, do the clearing out of the old ones. Again, you're going to have full control over how many backup copies you want, by age, by number, things like that. Okay, so almost done here, and then we'll get to a demo. K10 is sort of agnostic to what distribution you're running. So the good news is that if you're kind of in between, well, I like this platform over that platform, or you just want to keep your options open, it's quite okay, because we're going to operate in both places. So whether or not you want to use vanilla Kubernetes or DigitalOcean, you know, OpenShift is a very popular choice, and you know, any of these that you see on the screen we support. So the storage infrastructure, we don't really care about the storage infrastructure as long as that storage end has a CSI storage driver that Kubernetes relies on to provision storage. And so since we're Kubernetes native, we basically go to Kubernetes and say, hey, we need some PVCs and we need them at this size. And those requests are going to be handed over to your CSI driver to provision those. And so all of those have been pretty well understood by all these different storage vendors. So we really haven't seen too much of an issue as long as you're using a recent CSI compatible driver. So whichever direction you're at now, whether you're an on-prem shop, whether you're a classified shop where you've got air gap situations, you know, you're in aisle 4 or aisle 6, whether you're doing this on the cloud, whether it's in Azure government cloud, or whether it's a public cloud, all those places you can use Casten. Some places like OpenShift, we are inside the operator hub. Rancher, we're inside the marketplace, and on the cloud providers, you can just install us as an option. So it's very easy to install us. I'm actually going to show you how to do it. A lot of people like to use operators. Some people like to use Helm chart. Both of those are perfectly fine. Okay, so we're going to transition to a demo, and I'm going to go ahead and stop sharing the screen for, actually, it's not that I have to stop sharing, I just have to end this slideshow. Okay, so let me just explain to you what we have real quick. So I have on Azure, I have a cluster. I also have a cluster that is on-prem. I'm calling it my East Coast cluster. Take a quick look at it. You can just see, well, right here, you can see it's got the default, it's got Casten on it. I've got 2 applications, MongoDB and Postgres. And this is sitting here in my home lab. And this has got MongoDB, which I've got up here. And we've got an accounting and an HR database. These 3 are kind of the default. And this is just the application we're going to use to back up and restore. So I'm going to jump over here. This is the Azure cluster. And I'm just kind of showing you a little bit about what the environment looks like. And here we have our on-prem. You can kind of see it by the IP address here. That's an on-prem. Okay, so how do we back up? Well, let's see here. Let's start with, this is the main dashboard. You're going to see that K10 is going to inventory all the namespaces that exist, and then it's going to display them for you here, and it's going to give you a little summary inventory of what's in the namespace. And when you go to do a backup, this is what K10 is going to go back up. It's going to back up the workloads that are in there, the networking information, the config information. You can see there's config maps and secrets. And basically, the idea is it's not just bits, right? Here's a PVC. These are bits, okay? That's very important. What we want to back up is the state of the application, how it got installed, because when you do a restore, we want to have this application running for you. and we are going to restore it in the same fashion that you deployed the application to start with. So if you used a deployment set, if you used a stateful set, these are things that we're going to mimic as well. Now you can filter and do things like, I don't want you to back up that other information. All I care about are the bits, and that's totally up to you. You can do whitelist or blacklist, but the default is simply just to go ahead and grab everything. Okay, so how do I do a backup? Well, I got a couple of options. I can just simply do a snapshot right now, and that will grab all of this information and store it inside the namespace of the cluster. But what's a little bit, call it more modern, is to use an automated approach where you define a policy, and the policy will automatically do the backups for you at a rotation time that you specify. So let's just spend a second looking at a backup policy here. You can see this is the name. You can put comments in. I have these set to on demand, but you are welcome to set these to whatever time interval you want. Like I said, if you want every 5 minutes, you're welcome to do it that way. You could set it for daily, twice a day, weekly. And obviously this choice here is going to affect your retention, your snapshot retention, how many you want to keep, dailies and weeklies and the likes. I'm going to put this back on demand. The second thing here, which is very important, is after we've done the snapshot locally, would you like us to export a copy of the data out of the cluster? And the answer to that is yes, yes, and yes, yes. It is simply paramount for you to get a copy outside the cluster. This is what I talked about earlier, the endpoint that we can deposit this information can be Veeam, VBRs, it can be any of the cloud providers. I'll actually bring up the options here in a second. But I'm depositing this into Azure, an Azure blob space. Okay, so this policy is going to run and do 2 backups, one locally and one externally. What am I going to be backing up? Well, I'm backing up the entire namespace of MongoDB. Now, I can say back up multiple namespaces with one policy, but that's going to group these namespaces into the same frequency that you set here. And I'm sure your applications, some need backup more than others. So maybe your SLAs are different. So you're welcome to group these here. Another option you have, and these are the shops where the developers like to sort of make most of the decisions, is you can do it by labels. And by labels, what happens is that what you're saying is run through all the namespaces, and if a label exists, then go ahead and back it up. Now that label is a name that you make up. So if a developer says, hey, this namespace is worthy of a backup and I'd like it to be daily, then you're probably going to make a label something like this. And so if that label exists on the namespace, K10 is going to back up everything in that namespace. If the label doesn't exist, it just skips over it. So you can tell your developers, you decide which namespaces you want to have backed up. So I'm just going to go back into here and go back to my Mongo. I mentioned earlier we can do whitelist or blacklist. This is where that happens, include and exclude. I can say I don't want anything backed up except for I would just like the persistent volume claims backed up. And I could even specify a particular persistent volume claim if I wanted to. Or I can do the other way, which is back up everything except, you know what, I don't need secrets. I don't need config maps. So don't back those up. So that, again, that's your choice. And then a topic for, probably another webinar is when applications require some extra work, like they need to be QS'd, they need to run a third-party utility like a PG dump, an RMAN, any utility recommended by the database folks, that is going to happen inside of what we call a blueprint. And so that blueprint is going to give you the flexibility to go off and really do anything you want for the backup. So if you need to do some actions ahead of doing a backup, switch users over to another instance to make sure the database is in a good, healthy state, we're going to use blueprints to do that. Most applications are okay with snapshot-based, but not all of them are. And some of them, we need to do a blueprint. And this is how and where we would activate it. Okay, so let's go ahead and get this going here. I'm just going to go ahead and do a run once. And run once means, well, I'm going to run a backup, but do you want me to clean it up at some point in the future? So I'm going to go ahead and say, yeah, go ahead, run till the end of the month. That's fine. And then go ahead and clean yourself up. Okay, so we are off and running now. And this is a little bit of paint drying moment here. So I mentioned endpoints. So let's go over here, and I'm just going to show you real quick. These are all the different places that you can, and you can have multiple, of these. So if you're a Veeam customer, first off, thank you. But if you have Veeam repositories, we can deposit into that. That's kind of a handy integration. And the Veeam repository is going to understand that Casten is the one depositing into it. But you can see here, you have all these different endpoints as options to export to. Policies are here, and policies are going to be how you create automated scheduled backups. It includes the retention, it includes the cleanup, it includes, is it going out? So like you can see here, local plus export, local plus export. So that's the policies, and that's the profiles. Okay, so while this is running, it takes about 2.5 minutes to run. Let's jump over to our Azure cluster and take a look here. I don't have really anything on it. I haven't done any kind of application migration. So, this Mongo database, I like it over here on Azure. So let's go ahead and do that. So I'm going to go ahead, just for the sake of time, I went ahead and created a policy, which is an import policy. And its difference is basically I'm using this import option here instead of the snapshot action. And I'm saying that after you import information about the application, go ahead and do a restore. And I can select the names. It's going to install into its normal namespace. But if we wanted in a different namespace, we could create one here. Very important, I am applying 2 transformations because my on-prem cluster doesn't have Azure storage, and my Azure cluster doesn't have my on-prem. So storage class is going to be different. The other thing is that on-prem, I am running the MongoDB via a node port option, but in Azure, I like to run it as a load balancer. So I am going to actually make that switch during the restore. So anyway, this is the key. This has some encryption information so that when we go out to the Azure blob, we can see the job and actually decrypt it, because when we store stuff, we store it encrypted and it's compressed and it's deduped. So we don't want nosy people coming in and getting this Mongo database, because it's got an HR database, and who knows, it could have some sensitive information. So we're going to go ahead and just go ahead and do this import right now. And now this is going to import a backup that was run a couple hours ago. If I wanted to, I could have it import the one right here that's running right here, and it's finished. So let's take a look at this backup. Okay, we're finished. So what happened during the backup? Here's what we did. We snapshotted and took the information of how the application is configured, the components around it, and obviously we did a PVC backup here, and then we went and exported it out to Azure, and you can see the policy name here kind of gives you that clue. Let's take a look at that. Now, we do differentials or incrementals, so even though this is a 1 gig PVC and there's about 371 megs written to that 1 gig PVC, you can see that we only had to transfer 83 megabytes, which is basically the deltas between this backup and the last backup. And K10 is going to keep track of, okay, I did a full backup, but that full backup is about to expire or has expired, and so I need to delete that full backup. So the export that I'm going to do, say run number 10, is going to be a full, because the previous full is about to fall off the table, and if it does, right, then your incrementals that are attached to it are not going to work. So now what we need to do is do a full so that those incrementals can stay healthy, and you can see we do this pretty efficiently. And then once that is done, we update our metadata, our catalog. It says these are done, and gives you a success. Okay, so that was a backup. Let's check over here and see how we're doing on our restore. We see we have the application, and now the restore is going to reload the pods using in this case, I think it's a deployment set, and so that is going to take a minute for those pods to come to life, attach themselves to the PVC. So that's basically what this is waiting for. So we'll come back to that. Let's spend a second on this transform sets, this application mobility. What exactly is that, and how can I use it when I'm migrating between clouds? Well, basically anything that is in the spec of the YAML file, we are offering to go in and interrogate and to do some checks and to do things like, in this case, I'm going to take the storage class name and I'm going to rename it to something that is local to my Azure cluster. So this is the storage class I'm using. So that's a very simple replace. You can stack transforms on top of each other. You can do things like tests if this value exists. In fact, let me show you that. We'll go back here to transform sets, node port to load balancer for MongoDB. What are we going to do? We are going to go in and look for a service, and we are going to test that the service name is this particular Mongo Express service. So if I apply this to a restore that isn't Mongo Express, this test is going to fail, and this replace and remove will never happen. And so I can apply it even though it's not going to work on, say, my Postgres, but I could also build one for Postgres. But under the replace side, you can see I'm replacing the spec type. Instead of it being node port, it's now going to be load balancer. And I'm actually going to go in and remove the node port reference because there's a port number that's in there, and we're wanting to remove that. Okay, so let's see here. How are we doing? Okay, we got our MongoDB. All right, so I think, did we finish? Let's take a look here. We are done. Okay, so let's take a quick look at that. So that is on my Azure cluster, which is right here. And just to make sure I'm not doing anything with smoke and mirrors, just going to show you here. I am attached to the West Coast Warm that is running in Azure. You can see here, this is Casten running on the Azure cluster. This is the IP address of the service, which is going to match up to this one right here, the 6211. Okay, so let's take a look. Let's see what happened here. First of all, let's just get the pods in the MongoDB namespace, we can see we have a deployment running. Okay, let's get the services that are running. And notice this is now a load balancer. It's not a node port. And so this IP address right here, I can just go here, type it in, and this will hopefully come up with a prompt for a name and a password, and that will be our Mongo database instance here. Just give it a second here, make sure it's running. Because it should look like just like this right here with these four. Let me just go ahead and just do that again. Boom. I think Azure is being a little slow here, because this will bring us right to the Mongo database interface. So we'll just give that a minute to go. And let's see here. Oh, so while we're waiting on that, we're back to our on-prem cluster. So let's go ahead and be that guy who goes in and says, oh, it's time to delete the Mongo database off the pre-production cluster. Let's go ahead and k delete namespace MongoDB off of here. Give it a second to just do that. I'm going to pull this guy off to the side here for a minute. I'll refresh that. Okay, so it's gone. It is gone. And now is the time that I realized, oh no, I am not in the pre-production cluster. I'm on the production cluster. I just deleted this application. Oh, is this a resume generating event? I don't know, but oh wait, we got Casten. Okay, so let's do this. Let's go to our applications. Yeah, I know I deleted it. Oh, bad by me. But it's under, so Casten has recognized I have all these backups for something called MongoDB, but that namespace in that application has been removed. So I can simply go in and say, I can restore it. Now, I said earlier that when we do snapshots, they are stored locally in the namespace of the application. So when I did this maneuver, I not only deleted the application, but I deleted all the backups for that application. But thank goodness I threw a copy out on Azure, which is not backed up. I'm sorry, which has not been deleted. So I can just simply do a restore here, and I can just select the defaults here, and I don't need to apply transforms because this is the same cluster. And also notice this is everything that we are going to do. We are going to restore all of this. Now let's say that you have a new secret and you're like, I don't want these old secrets. I could just uncheck these and they won't get restored. But for this, we're just going to go ahead and click restore, and off it goes. And it'll just take a few minutes to do the restore on that. And let me go back to where were we here? Let me check this. I'm getting some real slow connections to Azure at the moment. So my web browser is timing out. Let's just see here. Yeah, it's the same IP. I'll try it again. Okay, third time's a charm. Okay, so this is okay. So here's our database running, healthy, and you can tell by this IP address. This is on Azure. This is not on my on-prem cluster at home. So this is on-prem here. This is on Azure. So I just brought that application over. I made the adjustments to the fact that Azure has different, it's a different environment and it has different parameters. And also, you know, I could have changed replicas. I could have changed quota information. I could have changed annotations. Really anything that's in the spec area is a candidate to be changed. So very, very handy feature. I can give you a use case where one of my customers, what they do is their primary cluster is running, their secondary cluster is constantly doing this import, but in this import, they are changing the replica counts to 0 because the secondary cluster is in the cloud and they don't want to pay for the CPU consumption waiting for a disaster to happen. So we're automatically spinning everything down so that the pods are there, they're ready to go, but they're just not running, consuming you know, clock cycles. But we could spin it down to any number that you want, and we can spin it up to any number that you want. That's again up to you. In the case of a disaster, we do have the ability to quickly restore all the backup information that K10 is aware of. And to do that, all you would do is enable the Casten DR functionality. And you can see I have it enabled on this cluster. Basically what it's doing is it's going out to some endpoint, it's depositing a copy of the catalog, which contains all the backup information, and it does this in an encrypted method. You know, FIPS encryption #1, but also this passphrase has been added to it as well, because we don't want people who have K10 who have access to the same bucket to be able to go in, snoop in, and see those applications and possibly bring them in. They're going to have to know the passphrase. But once this is in motion and going, then what happens is we just simply have a policy that is automatically done called disaster recovery policy. It runs on the top of every hour. You can set it to, you know, run as often as you would like. But basically this is saying take a copy of our catalog and put it out there on that Azure blob or that endpoint of your choice. And so if we have to do a recovery, we can do that by importing this policy into a new cluster. And so really the steps to get you up and running from nothing to fully running is you deploy your cluster, say on Azure, you go through the steps, deploy, and you can add K10 at that time. You point K10 to the endpoint and say, in this endpoint is a catalog I need you to digest. It'll do that, and it'll say, I've got all these applications. Would you like me to restore them all? You can click one button at the top, which will highlight them all, and you can say restore, and it'll do them all. Or you can do them in groups if you've got some that have to be done in front of other ones, some that are more important than others. You can do that as well. Okay, so let's see. We were doing our restore here, right? So let's see. It looks like we are done here, or just about done. Okay, we're waiting for MongoDB to finish coming up. So the data has been restored. It's just the pods sometimes take a while to initialize. But let's go take a look. Let's see here. So I'm on my East Coast cluster. I've got my MongoDB there. Let's take a look at our pods that are inside the namespace of MongoDB. And you can see this is creating. So once this finishes, we will be good. And this will actually conclude the demo. I could have restored this to a alternate namespace. Very handy for things like, let's take MongoDB and let's clone it to a namespace called MongoDB test. And that way I can go inside of that namespace. I can muck around with that instance of Mongo, see what's wrong, or see what got corrupted, or see how I can make it better, or whatever. And then when I figure out what that work and what was the right thing to do, I can then go apply it to the MongoDB namespace, or I can just, delete it. You can restore it any number of times to any, different namespaces that you want. So, inside the cluster, to another cluster, between clusters, all of that is good. Okay, so we are running, so we're going to go ahead and get our services in the MongoDB database. If I spell it right, we will get that info. Okay, notice this is a node port, which is how I intend to run it here in my home lab. So I'm going to go to here. Now this was the original one that I deleted. Obviously this doesn't work anymore, right? This is broken. This is gone. But when we redid the restore, we went to a different port because node port does that. But you can see, okay, I don't have to update my resume. 5 minutes loss. Maybe nobody will notice. I don't know. So that is the in-place restore, and that's going to conclude our demo. So let me bring up the questions here. Does Veeam backup tie in with Veeam 1? Yeah, it ties. Yes, it ties in. Basically, we define. You can go into your profiles here, and you select repository. Then you're going to just have to answer a few questions, basically credentials and stuff of how to get into it, things like that. Okay, one person says they're not getting what I'm sharing, but I think that's been answered. So yeah, full integration into, I say full, Veeam VBR is a perfectly valid endpoint as well as any other ones. So feel free to use that. We want our Veeam customers to feel like, these products are integrating together. Veeam can recognize a Casten K10 instance. It'll show you the policies that exist. It'll show you the backups that have been run. And it'll also show you, hey, inside of my repo, I've got 5 gigs consumed by Casten. And those 5 gigs compose of, this namespace and that namespace and another namespace, on and on. Okay, any other questions? Going once, going twice. Okay. Well, I want to thank everybody for joining. I want to thank everybody for putting up with my little quirks here, and my home internet connection, I guess, flaked for a few seconds there, but no harm done. You can see it's up and running here. So thanks everyone. I hope. Let me just finish with a very small thing. docs.casten.io is where you're going to want to go if you just want to learn about Casten in general. You can install the product and you will have like a 30-day license to run. You will actually, if you have less than 5 worker nodes, then you'll have a much longer run time, like the rest of your life you could run for. So we're licensed based on the number of worker nodes. So we don't count how much storage you have, how many pods you're running, nothing that complicated. Is just simply a worker node. So your master nodes, your infrastructure nodes do not count. And if you'd like to look at a few blogs, let me look at what other people have done, and I'm interested in some particular subject here. How do I do it in air-gapped environments? Like how do I do, with this product or that product? Go to Veeam Kasten.dev. Good resource site. Okay, thanks everyone. I will give you your 4 minutes back. Take care.